Hello again, welcome to another lesson in Algebra 1. Today we're covering section 4.2, graph linear functions by plotting points. So we did about half of this lesson in class last time, and then we're going to extend it to learn about domain and range, which can be a little bit tricky. Okay. All right, so first one, warm-up says graph and plot each ordered pair. Ordered pair, another word is point. Graph, another word might be plot on the 10 by 10 grid below, and another word for the 10 by 10 grid or any grid could be called the coordinate plane. Okay, so remember they're called ordered pairs for a reason, and that is because the first number tells us about left and right, so the input, the x, going left and right, and the second number tells us about the y, which is the output, and that's going up or down. So we come in order, left and right point, number first, and up or down point, or up and down number second. Okay. All right. So we're going to do 5, 3. So we start at the origin, the middle of this. We would count 5 to the right and 3 up, and this would tell us where to put the point A. Okay. Now, of course, we don't draw in the 5 to the right and the 3 up. We just stick it on the 5 to the right and 3 up spot. Okay. B is 2 to the left and 2 up. So from the origin, I would go 2 to the left and 2 up, and that would tell me where to put B. Once again, we don't draw in the lines though. Okay. C is 1, negative 4, so I start at the origin. I go 1 to the right and 4 down. Okay. And we don't need to put the lines. Notice each one of these points I started by going to the origin. That's why it's called the origin. That's the beginning. Okay. 0, negative 8 is 0 left to right and then 8 down. So that's point D. Okay. Number 5 said to name and label the parts of the coordinate plane. So the coordinate plane are broke into 7 parts. Okay. We have these parts, quadrants. Quadrants start with number 1 and go all the way to quadrant number 4. They use Roman numerals to name them. So I'm going to shorthand this to save a little time on the notes. Quadrant 3 and quadrant 4. Okay. Where the quadrants overlap, we end up with the axes. We have the x-axis and the y-axis. Okay. And where the axes overlap, we end up with the origin. Okay. So we'll go back up here and label all these parts in red. Okay. So quadrants start like this. There's Q1. Here's Q2, here is Q3, and here is Q4. And the way I remember the order they go is the quadrant or the coordinate plane flies over the C. So if you connect your quadrants, you get a capital C. So the coordinate plane, this whole thing, flies over the C. Okay. Now, where the quadrants overlap, we get the axes. So in here, I'll draw the axis in green. This guy is the y-axis. Okay, it's where the quadrants on 1 and 4 over are boundary with quadrants 2 and 3. Okay, and this big line going through here is the x-axis, and that's the boundary between quadrants 1 and 2 and 3 and 4. So it's like the top half and the bottom half. And then where the axes overlap, okay, we get the origin. So we can name where the parts, where a point lies on the coordinate plane. So for instance, point A would be in quadrant 1, point B would be in quadrant 2, point C would have been in quadrant 4, and point D is on the y-axis. Okay, flip it over. We did these in class last time. So we are picking our own x's and then plugging it in to get the y and then plotting our points to graph the line. Remember, all these are linear functions right now. That means they create a line. So if yours is zigzaggy, you know you did something wrong. All right, so remember, we also said we're not allowed to use decimal or fractional inputs or outputs, so we have to be careful not to create them. And the trick here is to look at the coefficient on the variable term. What is the denominator, which is 2, and then we want to pick multiples of 2 for our input. Okay, so multiples of 2 here. And the 2 because that's the denominator of my coefficient on my variable term. So I'm going to pick negative 4, -2, 0, 2, and 4. I always pick them in a pattern because I should be able to find a pattern on the outputs when if I start it with a pattern on the inputs. So if the x's have a pattern, the y outputs will also have a pattern. So we plugged -4 in, and we showed work on this last time. So a -1/2 times -4 minus 2, that made 2 minus 2, which is 0. But you don't need to show this every time. You can just plug them in. So -2 times -1/2 makes 1, and 1 minus 2 is -1. If I plug 0 in, I'll get -2. If I plug 2 in, I'll get -3. And if I plug 4 in, I'll get -4. And you can see the inputs had a pattern of going up by 2, and the outputs have a pattern of going down by 1. So we know we did it right. All right, let's plot these points. -4, 0 is here. -2, -1 is there. 0, -2, 0 left and right, 2 down. 2, -3, so 2 to the right, 3 down. And 4, -4 is 4 to the right and 4 down. Okay, so notice these did make a straight line. So we connect them to get a straight line here. And rewrite y equals -1/2 x minus 2 by it. Okay. Number 2, we did one like this in class last time, and it had the same hint. Remember, if you write it as y as a function of x, it makes it easier to do the table. So let's solve for y here. That's why we spent a good bit of chapter 3 learning how to do that. So we'll subtract x to both sides to get -x plus 4. And then we'll divide by -2 to get 1/2 x minus 2. Okay, so it's almost like the function above, a little bit different. It's a positive 1/2 for the coefficient on the variable this time. And since the denominator of that is a 2, we're going to pick our inputs once again as multiples of 2. So I'll do -4, -2, 0, 2, and 4 again. Okay. Plug those in. You're going to get -2 minus 2 for -4. I plug -2 in. I get -1 minus 2, which makes -3. 0 will make -2. 2 will make -1. And when I plug 4 in, I'll get 0. So I can plot these. That's first one, -4, -4 is 4 to the left, 4 down. -2, -3 is 2 to the left, 3 down. 0, -2 is 0 left and right and 2 down. 2, -1 is 2 to the right and 1 down. And 4, 0 is 4 to the right and none down. Okay, so I'll draw my line. Okay. And label this x minus 2y equals 4. Now in both of these, we were allowed to pick any x's we want. There was no restrictions on our inputs, okay? Now the inputs are called the domain. So when we flip the page here, we have a key concept, domain and range. The domain are all of the inputs, and the range are all of the outputs. If you think about it alphabetically, D comes before R and I comes before O, so I know who goes with which. The domain is my input, my range is my output. The range and output comes second in the alphabet, okay? All right, so the domain of a function is a set of all the inputs, domain. The range is a set of all the outputs. Okay, so now we're going to regraph a couple of these, but we're going to have a restriction on the domain. That means this is all of the inputs we're allowed to pick. We have to only pick inputs that make this statement true. So what are numbers that make this statement true? Well, 0 is greater than or equal to 0. 1 is greater than or equal to 0. 2, 3, 4, 5, 6, and so forth, along with all the decimals that come in between these. Okay. Notice I didn't pick any negative numbers because a negative number input would not make that statement true. So I'll go ahead and pick the first one, 0, 1, 2, 3, and 4. I'll plug them in. 0 makes -2. 1, 3 times 1 is 3. 3 minus 2 is 1. 2 I plug in, I get 6 minus 2, which makes 4. 3 I plug in, I get 9 minus 2, which is 7. And 4 I plug in, I get 12 minus 2, which is 10. And that's great because it just barely fits on our 10 by 10 grid. We don't have to change the scale. Okay. All right. I'll go ahead and plot these. 0, -2. So that's 0 left and right and 2 down. Then we have 1, 1. That's 1 to the right and 1 up. And then we have 2, 4. That's 2 to the right and 4 up. And then 3, 7. That's 3 to the right and 7 up. And 4, 10. That's 4 to the right and 10 up. Okay. Here's our tricky part, though. My graph only covers this half. I have an arrow on one side, and on the other side, I just end it. Okay, and that's because my domain has an ending place. My domain ends at 0. That's the boundary. I'm not allowed to pick anything smaller than 0. Okay. All right, we're going to do the range, but I'm going to come back and do them both at the same time. And then we'll fill it in and help make a little more sense to see 2 examples in a row of the range. Okay. Here, number 4, same thing. This is not written as a function of y, y as a function of x, so let's change that. And I'll do it right here. Here's a little trick for this one. Notice everything's pretty much on the left side. We just have 0 on the right. So let's move the y part over. And then I don't have to do quite so many operations. So I subtract 2y to both sides, and 0 minus 2y is just negative 2y. We don't need to put plus 0 on there. We'll divide everything by negative 2, and we get 2x plus 3 equals y. Okay. Now, in this problem, we have even more of a restriction on the inputs we're allowed to pick. The smallest the input can be is negative 4. And the biggest the input could be is just smaller than 0. And it just so happens that we made this grid to fit perfectly in between. Now, why did I say just bigger than 0? And that's because on the 0, notice there's no equal to bar there. So we have to pick things smaller than 0 and bigger than or equal to negative 4 at the same time. So of course we could have picked some decimals in between negative 4 and 0, but those are hard to graph. So we picked the whole number ones to graph as our boundary points. Okay. So plug negative 4 into this function. 2 times negative 4 is negative 8, and negative 8 plus 3 is negative 5. Plug negative 3 into this function. 2 times negative 3 is negative 6, and negative 6 plus 3 is negative 3. If you plug negative 2 into this function, negative 4 plus 3 is negative 1. And if you plug negative 1 in here, you get positive 1. And if you plug 0 in here, you get 3. Okay, so our starting point was at 0, 3, and we could go up by 2s, but we got to see the up by 2 starting from back here going this way. Okay. All right, so we'll go ahead and plot these and see what happens. So negative 4, negative 5 is 4 to the left and 5 down. Okay. Negative 3 is 3 to the left and 3 down. Negative 2, negative 1 is 2 to the left and 1 down. Negative 1, 1 is 1 to the left and 1 up. And 0, 3 is 0 left and right and 3 up. But I'm going to put something special here. Okay, it's got an open circle. It means a circle that's not filled in inside it. Okay, and then we graph in between. And the reason why this circle is not filled in is because x less than 0 is the boundary, but I can't actually get to 0. So I leave an empty circle. So if you think back to your time of graphing inequalities in 7th grade, you'll remember when you don't have the bar, you don't fill in the circle. And the same thing happens in 2D graphs here. So that means that's the boundary point, but we don't actually reach the boundary. When we have the equal to bar, we are allowed to reach the boundary, so we fill that circle in. When we don't have the equal to bar, we leave that circle empty. Okay? All right. So let's look at domain and how it looks like on the graph here. So on this graph, we'll do our domain in blue. The domain are the inputs. That's the left and right. Okay? Notice it goes between negative 4 and 0. So if I drew little dotted lines down to here to show the distance from left to right, I can say, oh, look, it goes between negative 4 and 0. Okay? Same thing up here. Let's take a look at our domain. Our domain is the left and right. So the farthest to the left it goes is 0. And it goes on forever in the other direction. So that's why we have a boundary only on one side. Okay? All right. Now range was our outputs, are up and down. Okay, the y's. So in this case, our y's start here. and they go on forever. There's no limit for how high it can get. That's what that arrow means. So our range is going to be y, and it's always going to be bigger because it keeps going up forever. Sometimes it'll be equal to, and where does it stop on the way down? Well, it stopped at -2. Okay, notice 0 was our boundary for our input. -2, which goes up with 0, is our boundary for our output. Okay. All right, down below here. Okay, same thing. The range we got to find, so that starts at -5 and it ends at 3. -5 was filled in and -3 was not. So our range has a lower bound of -5. You can see it right here. It corresponds with a -4. An upper bound of 3. You can see it right here. It corresponds with our 0. Those come from the -4 and 0 there. Y is in between. And now let's see. -5 was filled in, so this gets the bar. And 3 was not filled in, so it doesn't get a bar. Okay. Now we will practice more of these next time in class, but you really should go back and watch a little bit of this to make sure you understand the range and domain. Now I'll practice a little more range and domain with you, but they're not going to be involved in what you graphed ahead of time yourself. So we have a graph in number 5, and we want to find out the range and domain. So remember, the domain is all the x coordinates. So the x coordinates go left and right. So this is the most left it gets, and this is the most right it gets. So I'll draw some arrows down just to show where they are. And the most left it gets is -7. And the most right our graph gets is 8. So our domain goes between -7 and 8. Okay, the x falls somewhere between those two things. Both of them were filled in, so we have equal to bars on both. Okay. Now our domain, the up and down, the most down this graph gets is right here, and the most up it gets is still right there. So let's draw over. So this is at 1, and this is at 7. So our range goes between 1 and 7. Okay. The inputs are the left and right of the graph, and the outputs are the up and down of the graph. Okay. Number 6, domain and range again. Okay. So the domain is the left and right. The farthest left our graph goes, that's over here, is at -7 for the x coordinate of that point. And the farthest right it goes is here. And that x coordinate is at 1, 2, 3, 4, 5, 6. Okay. So our domain is between -7 and 6. Now our ranges are up and down. The farthest down it goes is once again at this point, which is at -4. And the farthest up it goes is once again at this point, which is at 1, 2, 3, 4, 5. So our range goes between these two things. We're allowed to have all those outputs that go between -4 and 5. Now notice this time we didn't have y there, we had f. So this is our function f at input x. So the output is f and the input is x. Okay, it's just like y in disguise. Okay. All right, our last one, we have h is our input, and m is our output, which m is a function of h. Okay, so let's see, left and right. The farthest left this goes is right here. Okay, this is at -8. The farthest right this goes is right here, and that is at 6. So the domain is between -8 and 6. The range was our up and downs. The farthest down it goes happens twice. It's right here and here. So this spot and this spot, and that's at 2. And the farthest up and down it happens is at a bunch of spots, here, here, all of that stuff, and that is at 4. So our range goes between 2 and 4. Okay. All right, now you have to practice these a little bit. And to give you some practice, we have a Khan Academy recommendation. All right, it will not be due at next class. It will be due at the end of the day of next class day. So if you don't finish it, which you should, but if you don't, you have until through advisory that day, okay, or whatever the end of that day is. All right, see you in class next time.